Hi students, today we will learn about similar triangles specifically. So we're going to use what we learned about similar polygons and apply that to triangles. We're also going to learn about 3 shortcuts. So remember last time we talked about similar polygons. Polygons are similar when these 2 criteria are met. 1, the corresponding sides are proportional. Remember what proportional means. I can set up a proportion with equal ratios that are made up of side lengths, okay? And those ratios will be equal. Also, corresponding angles are congruent. So remember what that means. That just means the angles are all the same. On one shape, they're all the same on the other shape, the ones that correspond. So sometimes, though, you don't know all the measures of all the sides and angles. So this is where we have some shortcuts to kind of help us. And there are 3 that we are going to learn about. I want you to think back to when we to the unit when we learned about congruent triangles. Congruent triangles, not similar, but congruent. And we learned about SSS, SAS, and ASA. Those were the shortcuts. We have some similar kind of shortcuts to prove that triangles are similar. So that's what we're going to learn about now. The first shortcut we'll learn about is the AA similarity theorem. Okay, A and A, as you probably can guess, stands for angle, angle. Okay, it's really important that similarity comes after AA. I also sometimes, well, most of the time, will just use the similarity symbol, so I don't have to write out the word similarity. But what this means is if I have 2 triangles and they each share 2 angles that are congruent or equal in measure, like the picture here, then that's enough information to say that the 2 triangles are similar. I don't need to know anything else about the other angle measure or any of the side lengths. That's enough information. Now, if you think about this, though, if you know that there are 2 congruent pairs of corresponding angles in a triangle, because all the angles in a triangle add up to 180, you also should know that these third angles will also be congruent, right? Just because they both have to add up to 180. But all we need to know about is just that we have 2 pairs of congruent angles. That means the triangles are congruent. So let's try an example with that. I'm sorry, not congruent, similar. Sorry guys, remember similar means they are the same shape, but they're different sizes. Not to be confused with congruent, which means they're the same shape and the same size. Okay, so similar shapes have different sizes, just to clarify. So in this example, can the triangles be proven similar by AA similarity? If so, write a similarity statement. A similarity statement is very similar to a congruency statement. You're just going to match up the corresponding vertices, right? So we'll do that in just a second. Okay, let's take a look at A. We are looking for 2 pairs of angles that correspond that are congruent. So first off, I can see right here, they both have this pair of angles that are congruent by the arc measure or by the arc markings. Even if those weren't marked, I know that those are vertical angles, so those would also be congruent. So that's something you'd want to look for maybe if they're not marked. Vertical angles, remember, are always congruent. So there's one pair. And then I see these little boxes. I know those represent 90-degree angles. Well, 2 angles that are both 90 degrees are also congruent. So I have 2 pairs of corresponding angles that are congruent. So by the AA similarity theorem, I can say, yes, these triangles are congruent. Now let's write the similarity statement. So your similarity statement might look different than your neighbor's, but the corresponding vertices need to be in the same position. So it doesn't really matter how you name them as long as they correspond. So for example, on the left, I might start with the top triangle, and that's up to you as well, which triangle you want to be on the left and on the right. So just name one of the triangles first. So I'm going to name the top one ACE. And then when I name my second triangle, I need to really pay attention to the order of the vertices. So I know that the A on the top triangle is going to go with the D on the bottom triangle, so I'm going to put that first. The C on the top triangle, because that's that right angle, it's going to go with the B on the bottom triangle. And then the E on the top triangle is going to go with the E on the bottom triangle because they share that vertex. So that would be what that looks like. All right, for B, on this one, I don't have anything marked as far as my angles are concerned, but I do have these symbols here. And if you recall, those indicate that these two lines are parallel. So we're going to have to use some of the things that we learned about last semester. When you've got parallel lines with transversals, you've got some congruent angles. You've got some of those special angle pairs. So if I, for example, look at this as one of my transversals of those two parallel lines, I should remember that these two angles are alternate interior angles and they are congruent. So there's a pair right there. If I look at my other transversal, I can also see that I've got another pair of alternate interior angles. Those are also congruent. And then I even have a third pair of angles that I know are congruent. These two in the middle, because these are vertical angles. So I actually have 3 pairs. All I need is to know that I've got 2 pairs of congruent angles. I've got a little bit more information than I need. But as long as I have at least 2, which I do, then I can say that these triangles are similar by AA similarity. So let's go ahead and set up our similarity statement. If you want to try this on your own, that's fine. Yours might look different than mine, but just make sure that you've got the corresponding vertices in the same position. It also doesn't matter which triangle you put on the left or the right of your similarity statement. So I'm just going to start with the one on the left. I'm just going to call it JHK. Now, when I name my other one, I need to be really careful. So I see that the J on the left triangle, because that has 2 arcs for that angle, it's going to match up with this one on the right. I can't even see that. Let me erase. Which is F. So I know that the J and the F correspond. Then I look at the H. H is the vertex that they both share, so I know that those go together. So H matches with H. And then the K is my 1 arc angle. That's going to match up with my G, my other 1 arc angle. So that's an example of proving triangles similar by AA similarity. So not only will you need to prove that triangles are similar, but sometimes after you've proven that they're similar, you'll have to find some missing measures. So that will kind of go back to the similar polygons notes. So let's look at this one. We're not told we have similar triangles, but we are told that segment AB is parallel to segment CD. So this is a lot like the last example we did. When we have those parallel sides, we've got some congruent angles. I know that angle B and angle C are alternate interior angles if this is my transversal. So there's one pair. I've got another pair of alternate interior angles with this transversal. That's angle A and angle D. So those are congruent as well. That's all I need in order to say these triangles are similar by AA. But I also have a third pair of congruent corresponding angles, and that's these 2 vertical angles in the middle. So I have plenty of information to tell that these 2 triangles are similar by AA similarity. So you've got to prove that first. Now that we know that they're similar, now I can set up proportions with their sides if I need to. So let's see what else it says. It says AB has a length of 4. AE has a length of 3x plus 1. CD has a length of 8. And ED has a length of x plus 12. Find AE and DE. In order to find AE and DE, I'm going to have to get the value of x. So this is where you would want to set up a proportion. Remember, similar shapes, set up a proportion with corresponding sides. So let's first figure out which sides are corresponding. The 4 that represents AB connects my 1 arc and my 2 arc angles. So the corresponding side on the other triangle would be the 8, which is CD, because it also connects my 1 arc and my 2 arc angles. So the 4 and the 8 correspond. Maybe I will make those into a ratio. All right, so I put the 4, which is from the left triangle, over the 8, which is from the right triangle. So when I set up my ratio on the other side of the proportion, I need to set it up in the same way. Just because of what we have left, it's very easy to see that probably the 3x plus 1 and the x plus 12 correspond, but let's just make sure. The 3x plus 1 connects the 2 arc angle to the 3 arc angle, and the x plus 12 also connects the 2 arc angle to the 3 arc angle in my other triangle. So that means those two parts correspond. I need to make sure to set up my ratio on the right side of my proportion in the same way I set up the left side. So I'm going to put the 3x plus 1 over the x plus 12. So once you get a proportion that makes sense to you, and your proportion, you might have set it up a little bit differently. Remember, there's 8 good ways to set up a good proportion. There's also 8 ways to set it up incorrectly. But once you feel good about yours, then you can go ahead and solve. So let's go ahead and cross multiply. Remember, if you have any binomials in your proportion, make sure to put parentheses around them so that you'll remember to distribute. So one of my cross products is 8 times 3x plus 1. My other cross product is 4 times x plus 12. Remember, it doesn't matter which side of your equal sign you put which cross product. Now we're going to go ahead and solve by first distributing to get rid of our parentheses. 8 times 3x is 24x. 8 times 1 is 8. On the right, 4 times x is 4x. 4 times 12 is 48. So our parentheses are gone. Now we want to get all of our x's on one side. I have more x's on the left, so it would make more sense to move the 4x to the left by subtracting it from both sides. 24x minus 4x is 20x. And then I want to move my constants to the other side, so I'm going to subtract that 8 from both sides. So I've got 20x equals 40. And then the last thing I want to do is divide both sides by 20. 40 divided by 20 is 2. So x equals 2. Now remember, usually when you solve an equation, you're not done. That just gives you the value of a variable that you can then go back and plug in to find other measures. We need to find AE and ED. So we're going to plug in that value of 2 for x in both of those expressions. Let me get a different color. Okay, let's do it right here. So we'll put 2 here and 2 here. So for AE, we'll have 3 times 2 plus 1. 3 times 2 is 6. 6 plus 1 is 7. So AE equals 7. There's one length. And then for ED, we're going to plug in the 2 for the x, so we'll get 2 plus 12, which is 14. So ED equals a length of 14. All right, that's AA. So the second way that we can show that triangles are similar using a shortcut is SAS similarity. And I'm sure you can imagine that the S's stand for sides and the A stands for angle. So this is side angle side similarity. Now just like with the congruent triangle theorems, because the angle is between the two sides, it also needs to be between the two sides on the triangle. So notice my congruent angles are there. the proportional sides are on either side of the angle. Okay, so that's what that means. So what this means, in two triangles, if a pair of corresponding angles is congruent, so they equal each other, you just need one pair of angles that equal each other, and the sides, including the angle, on either side of the angle, are proportional, then the triangles are similar. So one thing that students kind of mess up or don't quite get all the time with this is when sides are proportional, that means their ratios are equal. So you have to set up ratios here. It does not mean that the sides are equal. They will not be equal because the shapes are not the same size. But the ratios are equal, so you have to check that. And that's a piece that students forget sometimes. So let's see what this looks like in an example. Okay, in this example, can the two triangles be proven similar by SAS similarity? So first, identify your angle. And I see, yes, definitely we have a pair of congruent angles. That's easy to check. Now we're going to look at the sides on either side of the angle. To know which sides to put together, you're going to look at their relative size. So on the left triangle, 4 is the smaller of the two sides out of 4 and 6. On the right triangle, 6 is the smaller of the two sides out of 6 and 9. So the 4 and the 6 must correspond if these truly are similar triangles. So the first thing we want to do is make a ratio with those. It doesn't matter how you set it up, 4 over 6 or 6 over 4, just do it one way. And then you want to be consistent when you set up your other ratio. So there's one. Now I'm going to look at the other two sides, the 6 and the 9. I also want to set up its ratio in the same way I set up the other ratio. So I'm going to put the 6 over the 9. If I had chosen to put the 6 over the 4 for my first ratio, then for my second ratio I would put the 9 over the 6. Just be consistent. Now to see if these two ratios are equal, right, which would mean that the sides are proportional, remember all the different ways we can tell if ratios are equal or fractions are equal. I think the simplest way is to reduce. Remember, you can just type these fractions in your calculator and it will reduce for you. 4 over 6 simplifies to 2/3. 6 over 9 also simplifies to 2/3. So because they simplify to the same fraction, that means the ratios are equal, which means the sides are proportional. So we've got congruent angle and we've got proportional sides, two pairs. So we can say, yes, these triangles are similar by SAS similarity. Now we just have to write that similarity statement. So name one triangle first. I'm going to start with the one on the left. I'm just going to call it MNL. And then when I make my triangle name on the right, I just need to match up those corresponding vertices. So the M is going to go with the P, the N is going to go with the R, and the L is going to go with the Q. So there's that. The third theorem that shows that triangles are similar, so like our third shortcut, is the SSS similarity theorem, which stands for side, side, side. So you don't have to know anything about the angles. All you need to do is show that you've got three pairs of corresponding sides that are proportional. So if you can show that, then you can say with certainty that these two triangles are similar by SSS similarity. Remember what proportional means. That means their ratios are equal. You've got to show that they're equal, so you've got to set them up. Remember, the sides aren't equal, but the ratios are equal. So let's see what this looks like. So, are these two triangles similar by SSS? So we're just looking at the sides. You will know the side lengths of all three triangles, and you're going to make ratios with the corresponding sides. Remember, to know which sides correspond, you're going to look at their size. So the two smallest sides, which would be 3 and 9, we would want to make a ratio with those. Remember, you can make your ratio 3 over 9 or 9 over 3. Just be consistent with the other ratios that you set them up the same way. I'm going to do 3 over 9. And then my Another pair of sides that correspond would be the two that maybe are the biggest. So that would be the 5 and the 15. So I'm going to make another ratio with those in the same way that I made my first ratio. So I'm going to do 5 over 15. And then by default, my last two sides are also going to correspond. These are the middle sides, the 4 and the 12. So I'm going to set up my last ratio. So in order to see if these sides are proportional, we have to see if these ratios are equal. So we just need to, like I said, the quickest way is just to simplify each ratio. Type them in your calculator, press enter. 3 over 9 simplifies to 1/3. 5 over 15 simplifies to 1/3. 4 over 12 simplifies to 1/3. So because they all simplify to the same fraction, that means these ratios are equal, which means that these sides are proportional. So we can say, yes, these two triangles are similar by SSS similarity. Now we just need to write the similarity statement. Start with whatever triangle you want. I'm going to start with the one on the left. I'm going to call it STU, S-T-U. The S corresponds with the X, the T corresponds with the W, and the U corresponds with the V. Now this was easy to see because the triangles were oriented in the same direction, but sometimes you might have a triangle that's flipped or even turned. So I think highlighting the sides like I did will help you in those instances to make sure that you know which vertices correspond. All right, so we've got some examples here. This is a lot what your practice will look like. You'll have two triangles and you just have to determine if they are similar or not. And then how do you know that they're similar? And then you'll write your similarity statement. So look at 5. This is an example where the triangles are overlapping. So if you recall from our congruent triangles unit, one of the strategies for that one is to pull out the little triangle or to redraw them separately so that you can see them separately. I'm going to take that top little triangle and I'm just going to redraw it off to the side. W, X, V, and then I've got that 80 degrees right here. Okay, so let's go ahead and take a look and see. So I'm going to look at, I'm going to compare the big triangle to the little triangle, if that helps. Okay, so let's go ahead and see what they have in common. Now notice I don't have anything labeled or told to us about the sides. So we're probably not going to be able to use SAS or SSS. So let's consider AA. We do see that they both have this pair of angles that are both equal to 80 degrees. So there's one pair of angles. And then if you recall, when triangles overlap, a lot of times they'll share an angle. So they both have this angle X, right? And sometimes we forget about that, but that's another pair of angles that they both have in common that are congruent. So I've got two pairs of angles that are congruent. So by AA similarity, I can say, yes, these triangles are similar. So let's write the congruent statement here. I'm going to start with the big triangle. XZY is how I'm going to call it. X on the big triangle corresponds with X on the little triangle. Z on the big triangle corresponds with W on the little triangle. And Y on the big triangle corresponds with V on the big triangle. So that's one way that the similarity statement could look. All right, let's take a look at 6. 6 also has overlapping triangles. So again, we want to redraw the little one, or you can redraw both of them side by side if that helps you. Sometimes it can still confuse students. So the little triangle is LKM, and I'm also going to put the numbers on there. So I've got 6 and 10. Okay. So I can see, let's look at the big triangle for a second. That side, JL, has a length of 3 plus 6, which is 9. So that's how long that side is. And then the side LN on the big triangle has a length of 10 plus 5, which is 15. So that's important to kind of add those and know how long those sides are. So let's see which sides would correspond. The two short sides would be the 9 and the 6. So because I've got some sides here, remember, you're going to set up ratios and make sure that those ratios are equal, and that'll show you that the sides are proportional. So with those two sides, 9 and 6, I need to first make a ratio. I'm going to do the 9 over the 6 this time, the big one over the little one. And then my other two sides that go together, the big sides, would be the 15 and the 10. So I'm going to make another ratio with those the same way I set up the 9 over 6. So it'll be 15 over 10. So I only have two pairs of corresponding sides. So that would be an SS if these are equal. So for my other thing, I wouldn't be able to use SSS, but maybe SAS. And I need to remember that for overlapping triangles, a lot of times they share those angles. So angle L on both triangles are congruent. Okay, so that would be the A. Let me make sure now that the sides are proportional. So let's simplify both of those ratios. 9 over 6 simplifies to 3 halves. 15 over 10 also simplifies to 3 halves. So because these ratios are equivalent, that means the sides are proportional, and I've got that pair of congruent angles. So I could say that these two triangles are similar, yes, by SAS similarity. So let's set up a similarity statement. I'm going to start with the big triangle. I'm going to call it JLN. And then when I make my little triangle, when I name it, I need to make sure that the vertices correspond. So the J on the big triangle goes with the K on the little triangle. The L on the big triangle goes with L on the little triangle. And the N on the big triangle goes with M on the little triangle. So that's one way the similarity statement could look. All right, let's look at our last pair of triangles. So these triangles look like they're not oriented in the same direction. So this might be a good example of where you kind of flip them around so they're going the same way. So I'm going to redraw my guys. Okay, so let's see. I'm going to keep the little triangle how it is, just like this. And I'm going to turn my big triangle around so that I can see it a little bit better. So I'm going to just kind of maybe rotate it so that it looks like this. Oops. And for some students, this might be a little tricky. The F will go here, the H will go up here, and the E will go here. So let's put the numbers on here. Between H and F, that was 6. Between H and E, that was 10. And between F and E, that's 6 plus 6, which is 12. Okay. All right, so I've got 3 pairs of sides all labeled. So this one will probably be SSS similarity if the sides are in fact proportional. Let's first look at the 2 littlest sides. The 2 littlest sides on each triangle are going to be the 3 and the 6. So let me make my first ratio with those. I'm just going to do 3 over 6. The largest sides of each triangle are the 6 and the 12. So I'm going to make another ratio with those. 6 over 12. And then the medium sides are the ones that are left. That would be the 5 and the 10. I'm going to make a ratio with those. 5 over 10. Now I'm going to see if these fractions in fact are equivalent by reducing them. 3 over 6 simplifies to 1 half, 1 over 2. 6 over 12 also simplifies or reduces to 1 half, and 5/10 also simplifies or reduces to 1 half. So that means that these ratios are equal, which means the sides are proportional. So we can say yes, these triangles are similar by SSS similarity. Let's go ahead and write that similarity statement. I'm going to start with the little triangle. I'm going to call it EDG. E on the little triangle goes with F on the big triangle. When you're doing this part, look at the triangle that you redrew. Don't look at this guy because it's oriented weird and it might mess you up. D on the little triangle goes with H on the big triangle, and G on the little triangle goes with E on the big triangle. All right, let's try some application problems. All right, in this example, it just says solve for X and Y. It does not tell us that we have similar triangles. So first we need to prove that we do, and then if we do, we can set up some proportions to solve for the missing sides. I see that I've got overlapping triangles. I also see that I've got some parallel sides. Okay? Remember you always have some congruent angles when you've got some parallel lines and transversals. So if I look at this transversal, I can see that these two angles are corresponding angles. Corresponding angles on a transversal that cuts through parallel lines are always congruent. So I've got one pair there. If I look at this other transversal, I've got another pair of corresponding angles. So those are congruent as well. And then so by AA, I know these two triangles are similar. AA similarity. Okay, cool. There's also a third pair of congruent angles, and that's this angle C that both triangles share. Okay? All right, what I'm going to do, let me clean this up a little bit. I'm going to go ahead and separate my triangles so we can see this a little bit better. But let me go ahead and put my angle markings back. Okay, so what I'm going to do is I'm going to go ahead and redraw the little triangle. The DBC. And I'm going to put my markings on there. I'm also going to put the angle measures, the side lengths. I've got Y here, 3 and 4. Okay. So I need to find X and Y. So if I look at where X is this part of this side of this large triangle. We don't use parts of sides, we use whole sides. So this whole side right here is X plus 3. So we can represent that length with X plus 3. And that corresponds to the 3 down here. So those two sides go together. So I might want to start off for my proportion to make a ratio with those two sides. So maybe X plus 3 over 3. Now I need to find another set of sides that correspond that only have numbers. Okay, remember when you set up a proportion, you only want to have one type of variable. So I don't want to use any sides that have Y. So the other sides that I might use are this side that's 4 with this side that's 3 plus 4 or 7. So those go together as well. I need to set up my ratio with the 7 and 4 in the same way I set up my ratio with the X plus 3 and the 3. I put the bigger triangle side length over the smaller one. So I need to do that the same way on the other side of my proportion. I'll put the 7 over the 4. So as long as your proportion makes sense to you, it should be good. Let's go ahead and solve this one. Remember, if you have a binomial, put parentheses around it. All right, and we're going to cross multiply. So we've got 4 times X plus 3 as one cross product. And that equals the other cross product, which is 3 times 7, or 21. So there's one equation. So let's go ahead and solve that. We'll distribute the 4. 4 times X is 4X. 4 times 3 is 12. That equals 21. Let's move our constants to the right side since our variables are on the left. We'll move that 12 over by subtracting it from both sides. So 4x equals 21 minus 12 is 9. And then to get x by itself, we're going to divide both sides by 4. So x equals 9 divided by 4. We can leave it as the fraction 9/4. I'm totally cool with that. If you want to convert it to a decimal, I think it's 2.25, but the fraction is better. Now we're going to go ahead and set up another proportion to find y. Let me change my color up. Okay, so the y is this side, and it corresponds with the 8 on the big triangle. So I'm going to start off by making a ratio with those two. I'm going to be consistent with what I was doing in my other proportion. I'm going to put the top triangle over the bottom triangle. So that would be 8 over y. And then I can go ahead and use those two yellow sides again, because those have just numbers for the other side of my proportion, which was 7 and 4. So this proportion looks a little bit simpler to solve. Let's go ahead and cross multiply. Y times 7 is 7y. There's one cross product. That equals the other cross product, 8 times 4, which is 32. To solve for y, we're going to divide both sides by 7. And y equals 32/7. Feel free to leave your answer as a simplified fraction. I prefer that over decimal. So those are the values of x and y. All right, these are our last two examples. Are the two triangles similar? If so, what is the scale factor? Okay. Scale factor is just a simplified ratio of side lengths. That's all it is. All right, so if you'll notice in both of these, we don't have pictures. So the first thing we probably want to do is draw pictures. In example 9, the measures of sides of triangle ABC are 4, 5, and 7. The measures of triangle X, Y, and Z are 16, 20, and 28. Okay, so let's go ahead and sketch both of those. Don't worry about drawing them to scale. Now one should be a little bit bigger than the other, but don't stress too much. So for the ABC triangle, I'll call that one the one on the left. It didn't tell us where those sides 4, 5, and 7 are, so we'll just place them on there some way. It doesn't matter. And then my other triangle is XYZ, and its side lengths are 16, 20, and 28. So since we only know about side lengths, the only way we'll be able to prove if these triangles are similar is by SSS similarity. So let's first do that. Let's match up corresponding sides. So you're going to match up the two small sides, which are the 4 and the 16. Make a ratio. All right, the two long sides are the 7 and the 28. So set up another ratio. And then the two remaining sides, which are the middle sides, are the 5 and the 20, so set up your last ratio. Okay, let's simplify all these fractions just to make sure that they are equivalent. If they're equivalent, then our triangles are similar. So 4 over 16 simplifies to 1/4. 7 over 28 simplifies to 1/4. And 5 over 20 also simplifies to 1/4. So since these are all equivalent, that means the sides are proportional. So these triangles are similar by SSS similarity. So yes, they're similar. The second thing it said is, what is the scale factor? Remember, scale factor is just a reduced ratio of side lengths. Well, we have 3 of those up here, so we could say the scale factor is 1/4. Now, normally, remember, with scale factor, it's new over old, but we don't know how these were dilated. We don't know what's our original and what's our new shape. So you could write your scale factor as 1/4, or if you set it up the other way, it would be 4/1. So if it's not specified, you can give me either scale factor. They would both be considered correct. All right, the second one, again, we have a similar situation, so let's go ahead and set up our two triangles. We've got P, Q, and R. The side lengths are 3, 5, and 6. Then we have STU. The side lengths are 2.5, 2, and 3. All right, so let's make some ratios with the sides. Let's start with our two smallest sides, which are 3 and 2, and let's make a ratio. I think I'm going to do the bigger one over the smaller one, so 3 over 2. Our large sides are the 6 and the 3, so I'm going to make a ratio in the same way, 6 over 3. And then my remaining two sides are my middle sides. We're going to put those together also in a ratio. That would be the 5 and the 2.5. So I'm going to make a ratio there, 5 over 2.5. All right, let's go ahead and simplify these three fractions. 3 halves is already simplified. 6/3 simplifies to 2 over 1. I can already see my ratios aren't equivalent. And 5 over 2.5 also simplifies to 2 over 1. So while I have two ratios that are equivalent, one ratio is not equivalent. So these are not similar at all. All right. If you wrote down any questions, make sure you have those handy when you get to class. Now, I think our class is actually asynchronous, so please feel free to message me any questions that you have on this. All right, see you later.